Hello students, in this video I'm going to teach you binomial distribution. Fine. Now let us start with the properties of binomial experiment. Now there are actually four properties binomial experiment. There are four properties. The first one is the number of trials should be finite. So number of trials is finite. Now, for example, let's say um, a, a, a coin is tossed 5 times, a coin is tossed 10 times, or a coin is tossed 3 times. So here the number of trials are finite, isn't it? Or we can say in a bag containing 20 balls, 7 balls are drawn at random with replacement, or it can be 11 balls are drawn at random with replacement, or 12 balls are drawn at random with replacement or without replacement. So here the number of trials are actually finite. It can also be a die is tossed 3 times. So here number of trials is 3, or a die is tossed 20 times. Here again the number of trials is 20, which is finite, right? Or for example, let us say let's say 8 voters were interviewed at random. Okay, here number of trials, so we are asking 8 persons, so number of trials is 8. So that is the first property. So the number of trials should be finite, right? And the second property is, yeah, so this is the second property. So there are only, in every trial there are only 2 outcomes, and we call one outcome as a success and the other outcome as the failure. For example, let's say if we toss a coin 5 times, then the number of trials is 5, and there are 2 outcomes. One is either you will get a head or you will get a tail. So I can consider getting a head as a success, so which means getting a tail will be a failure. Or I can also consider getting a tail as a success. In that case, getting a head will be a failure, right? Or you can also consider tossing a die 6 times. So in this case, the number of trials is 6, isn't it? I'm tossing it 6 times. Now you may wonder, so how come when you throw a die there will be 6 outcomes, right? So how can you say there are only 2 outcomes? Now we can consider the outcomes as let's say if one outcome is getting 1, then the other outcome will be not getting 1, that is getting 2, 3, 4, 5, 6. So definitely we can consider this as only 2 outcomes. Or you can have one outcome as getting an even number, right? So 2, 4 and 6, and so that can be considered a success. So success is getting an even number, that means 2, 4 and 6. Then the failure will be not getting 2, 4 and 6, so getting 1, 3 and 5. So here there are only 2 outcomes, either the number will be even or the number will be odd. Or I can also consider getting a prime number as success as one outcome. That means you'll have 2, 3 and 5, they are prime numbers, so that can be considered a success. Then the failure will be not getting a prime number, that means 1, 4 and 6. So even tossing a die, we can consider that there are only 2 outcomes. Yeah. Or for example, let's say if 8 voters are interviewed, right? Either we can consider success as that they will support a particular party, and the failure as that they don't support the particular party. That means either they support another party or they don't support any party at all, right? So there are only 2 outcomes. So the number of, in every trial there are only 2 outcomes. So this is the second property. Okay, now this is the third property, students. Each trial is identical and independent. Okay, each trial is identical and independent. To give you an example, let's say tossing a coin 6 times. Okay, now the first trial is tossing the coin for the first time. The second trial is tossing the coin the second time. Now, don't you think that each time when you toss, the experiment is identical, isn't it? You're just tossing the coin, and also whatever happened in the previous trial is not going to affect the next trial, isn't it? Whether I got a head or tail in the first toss, that is not going to affect what I'm going to get next in the second toss. That means I may still get a head or a tail. So each trial is identical and independent. And finally, the fourth property is, okay, so this is the fourth one, probability of success remains the same in every trial. Okay, okay, let me again take a experiment of tossing a coin 10 times. Okay, here the number of trials is 10, which is finite. There are only two outcomes, getting a head or getting a tail, and each trial is identical and independent. Now, let us look whether this particular experiment will satisfy the fourth property or not. Probability of success remains the same. Let me take getting ahead as a success. Then the probability of success in the first toss is half. The probability of success in the second trial, that means second toss, is also half. So every trial, the probability of getting success, that means probability of getting ahead, remains half, isn't it? So here the probability of success remains the same. Okay, let us see an example where the probability of success will not remain the same. Okay, let us say in a jar you have 6 red marbles and 4 white marbles. Yeah, so you have a jar. So you have 6 red marbles and 4 white marbles. Okay, now the experiment is taking let's say 3 marbles at random without replacement. That means when you take the first marble, you don't replace it, you keep it outside somewhere, you don't replace that marble. Now in this experiment, the first property, the number of trials, is finite, isn't it? You are taking 3 marbles. And the second one, there are only 2 outcomes. Yeah, either you will get a red marble or you will not get a red marble. That means you will get a white marble. Now here, if I consider getting a red marble as a success, right, then the probability of success, that means the probability of getting a red marble in the first trial, will be 6 by 10, isn't it? Now if I want to find the probability of uh, getting a red marble second time in the second trial, now it can be either 5 by 9 or yeah, sorry, it will be actually 5 by 9, isn't it? um, or it can be actually 6 by 9, provided what happened in the first trial. Maybe in case if I had taken a white marble in the first trial, right, then if I don't replace it, then the probability in the second trial, probability of success will be 6 by 9. But if I had taken a red marble in the first trial, then getting a red marble again in the second trial will be 5 by 9. As you can see, 6 by 10 and 5 by 9 both are actually different, or 6 by 10 and 6 by 9 actually both are actually different. So here the probability of success changes, isn't it? So definitely this particular experiment, the fourth property is not satisfied for this. Okay, so now I hope you got an idea about binomial experiment. So these are the 4 properties of binomial experiment, right? Now a random variable x uh, which has above all these 4 properties of binomial experiment is said to have a binomial distribution, right? I have already taught you in another video what do you mean by a random variable, a discrete random variable. Yeah, so this particular, suppose if I say x is the random variable, right, then if it has all these 4 properties, that means the number of trials is finite, yeah, there are only 2 outcomes, and the third property is each trial is identical and independent, and the fourth one is the probability of success remains the same for all the trials. So if this random variable x satisfies all these 4 properties, then it is said to follow, it is said to have a binomial distribution. Okay, now let us consider this. Let x be, let us say the number of trials be n. Okay, now let's say probability of success be small p, and let's say probability of failure, Let it be small q. And it is very easy to note that p plus q will actually be equal to 1, isn't it? P plus q will be equal to 1. That means q will be 1 minus p. Okay, let x, the random variable, be number of successes. Number of successes in n trials. Now what values can x take? X can take 0, that means no success in n trials, or 1 success in n trial, or 2 successes, or 3, or 4, or 5, or 6, till n, right? The maximum number of successes can be n. Okay, now when I say p of x equal to 0, what do I mean? What is the probability that in n trials you will not have any success at all? That means every time it is a failure. That means the first trial is a failure, so the probability is q and multiplication. The second trial is also a failure, q, and the third trial is also a failure, and the fourth trial is also a failure. So every trial is a failure, right? Every trial. So totally there will be n trials, isn't it? So this will be equal to q power n. So probability of x equal to 0, that means probability of 0 success in n trials is q power n. So let me find p of x equal to 1. That means what is the probability that in n trials there is exactly one success? Okay, so it can be one success, so the probability is p, and the rest of them failures. That means q into q into q into q. So likewise into q. So there will be n minus 1 q's, isn't it? Now you will also notice that this p can come in any place. Now for example, I have put p here. That means the first trial is success, the rest of the trials are failure. It can also happen that the second trial is success and rest of them can be failure, right? That means q, let me write it here and rub it later, q into p into q into q into q, like that, right? This is also possible. Or I can also have the third trial success and rest of them failure. So likewise there are actually nc1 possibilities, different possibilities. So I can write it as nc1 p power 1 q power n minus 1, right? So p of x equal to 1 is this. Okay. Okay, the first question is, for those who do not have worksheet, maybe you can just listen to what I'm going to say and you can write it down, and then maybe you can then you'll be able to follow what I'm going to say, what I'm going to teach. At an election, 40% of the voters favored the environment party. Okay, let me repeat it again. At an election, 40% of the voters favored the environment party. 8 voters were interviewed at random. Find the probability that exactly 4 voters favored the environment party. That is the first question. So there are actually 3 questions. So let me finish the first one, and after that I'll dictate the second and third question, right? So let us look at the question again. 8 voters were interviewed at random. So here it is very clear that the number of trials is 8. So n equal to 8. Okay. Now 40% of the voters favored the environment party. Sorry. So I can have success as I can have it as, let's say, voters, if they favor the environment party, then that is called as success. So here the success probability is 40%, so 0.4. Then obviously the failure, that means those who do not favor this party, is 1 minus 0.4 is 0.6. Okay. Now let me write. Okay. Now when you consider this experiment, it is definitely a binomial experiment, isn't it? The first property, number of trials, is finite. There are 8 voters who are interviewed, so that is finite. The second one is there are only 2 outcomes. Either the people favor the environment party or they do not favor it, right? The third one is that each trial is identical and independent. So obviously, when you go and interview 8 people, uh, whatever the first person said, okay, it is not going to affect what the second person is going to say, right? Isn't it? Unless they are together, unless they are friends. But basically, uh, the first person or whatever the second person said is not going to affect the decision of the third person. So each trial is identical and independent. And the fourth one is the probability of success remains the same. That means when you go and interview the first person, the probability of that person favoring the environment party is 0.4. Now, when you go and talk to the second person, the probability that he will favor the same party is again 0.4. So the probability of success remains the same. So definitely this experiment is a binomial experiment. So the random variable follows a binomial distribution. Okay, now let us look at the first question. What is the probability that exactly 4 voters favor the environment party? Okay, before that, let me write the function. So P of x equal to x equal to ncx, that is 8cx, p, that is 0.4 power x, and 0.6 power 8 minus x. Now I need to find what is the probability that exactly 4 voters favor the environment party. So out of 8, what is the probability that exactly 4? So the first one is P of x equal to 4. Now you can either do this, put x as 4, so 8c4, 0.4 power 4, or 0.6 power 8 minus 4 is 4. You can calculate this, or the easiest way is using the graphic display calculator. Yeah. Now I'll tell you how to find the answer for this. Okay. Now please take your calculator, the Casio FX9860G2. Now what you need to do is go to menu and go to statistics, that means menu, and go to statistics, and then enter distribution. You'll have DIST, that is above F5, and then enter, press binomial. It will be written BINM, again above F5. Now when you press it, you will see 3 options: BPD, BCD, and then INV, inverse binomial. Okay. Now since you need to find for a particular value, that is 4, you press BPD, that is above F1. Okay. Once you press BPD, you will have the first one is data. Now there are 2 options, list and variable. You please enter variable, right? You're not going to use any list to find this binomial distribution, so press variable. And next you'll have x. You should write 4, isn't it? Because you want to find P of x equal to 4. And the next option is num trial, that means number of trials, which is actually 8, isn't it? 8 voters are being interviewed. And the next one is P, which is basically the probability of success, that is 0.4, right? And next one is save RES, that means the save the result, that you just write it as none. Okay, then press execute. Press execute. You'll get 0.3 significant, 0.232 as the answer. So the answer is 0.232. So probability of x equal to 4, that means 4 voters favoring the environment party is 0.232. Okay, so this is how you find it. Very, very simple. Okay, now the next question is, what is the probability that a majority of those interviewed favor the environment party? So what do you mean majority? If you take 8, the majority is more than 4, isn't it? Either 5, 6, 7, 8. That means I need to find the probability of x greater than or equal to 5, isn't it? Okay, 5, 6, 7, 8. But the best way is I can find 1 minus P of x less than or equal to 4, right? If you want to find 5, 6, 7 and 8, what I'll do is I will find 0, 1, 2, 3, 4 and then add them and then subtract it from 1. You may wonder, sir, what is it? Then, if it is only 5, 6, 7, 8, then you need to find for 4 different. I mean, 4, 5, only 5, 5, 6, 7, 8. But if it is less than or equal to 4, then you need to find 0, 1, 2, 3, 4. So isn't it tougher? Definitely not, because you can use the calculator for x less than or equal to 4. Okay, I'll tell you how to do that. Now what you do is, again take your calculator, go to statistics, go to distribution, go to binomial. Now you need to go to BCD, not BPD, BCD. Okay, so press BCD. Now here you should write the number of trials remains the same, the probability of success, that is P, remains the same. Now in place of x, you should again write 4. Okay, and then execute. You will get 0.826 as the answer. Okay, now you may wonder, what is it, sir? Earlier we put x as 4, we got a different answer. We got, I think, 0.232. Now again we are only putting 4 and then you are getting a different answer. Now that was BPD. That means you are finding only probability of x equal to 4. Now this is BCD, which means when you put x as 4, you are actually finding the sum of the probabilities of 0, 1, 2, 3 and 4. Right? So when you put 4, you find 0, 1, 2, 3, 4. So if you put 3, you will be actually finding 0 plus 1 plus 2 plus 3. The probabilities of x taking those values. Right? So you subtract it from 1 and you get the answer. So basically this is nothing but 0.174. So very simple. Now let us look at the third subdivision. Now the third one is, what is the probability that at most 3 of them favored the environment party? At most 3. So P of at most 3. That means maximum 3. So which means P of x less than or equal to 3. So at most 3 means, as I said, maximum 3. That means either 0, 1, 2 or 3. Now again, how do you calculate? Very simple. Go to BCD, okay, and put x as 3. So you get 0.594 as the answer. Okay, very simple. So this is how you do it, students. I hope you understood this sum. Now let us go to the second problem. Okay, the second problem is, in the long run, Thomas wins 2 out of every 3 games. If Thomas plays 5 games, find the probability that he will win. There are 4 subdivisions: that he will win exactly 4 games, that he will win at most 4 games, he will win no more than 2 games, or he will win all 5 games. Okay, so let me repeat the question. In the long run, Thomas wins 2 out of every 3 games. That is, probability of Thomas winning a game is 2 by 3. If Thomas plays 5 games, that means the number of trials is 5. So n equal to 5. Then I can take success as Thomas winning the game. Let me write it in shorthand. So Thomas win. So P is 2 upon 3. So definitely Q will be 1 minus 2 upon 3. That is 1 upon 3. That is probability of Thomas not winning is 1 upon 3. Okay. Now I need to find what is the probability that he will, first one is, what is the probability that he will win exactly 4 games? That means P of x equal to 4. Now how do you do it? Very simple. As I mentioned, you need to find a particular value. So go to statistics, go to distribution, go to binomial, and then press BPD now. Okay, press BPD, and then you need to enter x as 4 now. Okay, enter x as 4. Then you enter the number of trials. Number of trials is actually 5, isn't it? Out of 5 games. And then you write P as 2 divided by 3. So 2 divided by 3. So you'll get 0.1707. So 0.171. as the answer. So probability that he will win exactly 4 games is 0.171. Now the next one is, what is the probability that he will win at most 4 games? So P of at most 4 games. So at most 4 games. Okay, that means P of x less than or equal to 4. Again, how will you find it, student? X less than or equal to 4 means P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3 plus P of x equal to 4. So here you need to go to BCD, right? Go to BCD, put x as 4, and then a number of trials and P remains the same. Number of trials is actually 5. Okay, so you get 0.868 as the answer. Okay, fine. Yeah, so that is the answer. Now let's look at the C part now. What is the probability that he will win no more than 2 games? That means he cannot. What is the probability that he does not win more than 2 games? That means he can either win 2 games or 1 game or no game. That means P of x less than or equal to 2. Now again, how do you find it? Very simple. Go to BCD, distribution, binomial, go to BCD, substitute x as 2. The number of trials and probability of success remains the same. So the answer is 0.209. Okay. So finally, you have, what is the probability that he wins all 5 games? That means I need to find P of x equal to 5. So what do? Go to calculator, statistics, distribution, binomial, enter BPD. Then enter x as 5. So execute, you get 0.1316 or 132 as the answer. Yeah, very simple. Now in fact, I forgot to tell you something, students. Maybe before we started doing this problem, I should have told you that this is actually a binomial experiment, isn't it? Okay, let us recollect. Binomial experiment, there are 4 properties. The first property is number of trials is finite. Now here Thomas plays 5 games, so number of trials is 5, which is finite. The second one is there are only 2 outcomes. Now again here, either Thomas wins or Thomas does not win. Okay. Now the third one is each trial is identical and independent. Now Thomas plays 5 games and the probability that he will win is 2/3 in every game. So whatever, let us consider this as 5 sets. So whatever happened in first set is not going to affect his chances in the sort of second set. That means if, let's say, if he loses the first set, the probability of that it doesn't mean that second set also he's going to lose. Yeah, he can actually win or lose. The third one also he can win or lose. So it is identical, all trials are identical. And the fourth one is the probability of success remains the same for all the trials. In the first game, the probability that he will win is 2/3. In the second game, the probability that he will win is again 2/3. Third game, again 2/3, like that. So definitely this is a binomial experiment, right? I hope this is clear to you. Okay, fine. Let us look at the third question, students. A bag consists of 6 white cubes and 10 black cubes. Okay, there is a bag. It has 6 white cubes and 10 black cubes. Okay, now 4 cubes are withdrawn one at a time with replacement. Now this word with replacement is very important. Yeah? Whenever you find without replacement, you can close your eyes and say that it is not a binomial experiment, right? But here it is with replacement. Cubes are withdrawn one at a time with replacement. Find the probability that after 4 draws. Okay, so that means the number of trials is 4. So n is 4. Number of after 4 draws, all the cubes are black. There are at least 2 white cubes, and the third one is there are at least 2 white cubes given that there was at least 1 white cube. Slightly complicating. Okay, anyhow, let us do it, not an issue. So what I'm going to do is I'm going to take success as getting a white cube. Okay, not a black cube. I'm going to take success as getting a white cube. Then the probability of success will be 6 upon 16, isn't it? There are totally 16 cubes. So probability of success, that is probability of getting a white cube, is 6 upon 16, which is nothing but 3 upon 8. That means the probability of failure, that means not getting a white cube, will be 1 minus 3 by 8, which is 5 by 8. Okay. Now the first question is, what is the probability that all cubes are black? Right? What is the probability that all cubes are black? So all cubes black. That means there is no cube which is white. So P of x equal to 0, isn't it? All cubes are black means no white cube. Okay, so how do you find it? Now this is a particular value. So go to statistics, go to distribution, go to binomial and enter BPD, not BCD, enter BPD. Then you can enter x as, here you need to find 0, right? So x as 0 and number of trials is 4 because 4 draws, and then probability of success is 3 divided by 8. So I'll enter 3 divided by 8, and then when I enter I get 0.1525, so 153 as the answer. Yeah, it's very, very simple. The second subdivision is, what is the probability that there are at least 2 white cubes? So P of at least 2 white cubes, at least 2 white cubes. That means P of x more than or equal to 2, right? That means either 2 or 3 or 4. Now is it not easier, but when we use BCD we can only get from 0, right? 0 1 2 or 0 1 2 3 or 0 1 2 3 4. So what I do is I can write this as 1 minus P of x less than or equal to 1, isn't it? Either you find 2 3 and 4, or you find 0 and 1 and add them and subtract from 1, you get the answer. So what you do is go to statistics, go to distribution, go to binomial. Now enter BCD, not BPD, BCD, and then enter x as 1. Okay, number of trials and probability of success remains the same. So you get 0.5187, so 519 as the answer. So that means the final answer is 0.481. Probability of getting at least 2 white cubes is 0.481. Okay. Now the last question. What is the probability that it's a conditional probability, there are at least 2 white cubes given that there was at least 1 white cube? That means what is the probability of that there are at least 2 white cubes? That means P of x greater than or equal to 2 given that there was at least 1 white cube. That means x greater than or equal to 1. Okay. Now we know that P of A over B is P of A intersection B divided by P of B, isn't it? Same rule let us apply here. So P of x greater than or equal to 2 intersection x greater than or equal to 1 divided by P of x greater than or equal to 1. Now how do I find it? Very simple. Now what is the intersection of this and this, students? X greater than or equal to 2 means 2, 3 and 4. X greater than or equal to 1 means 1, 2, 3, 4. So the common is 2, 3 and 4. So P of x greater than or equal to 2 divided by P of x greater than or equal to 1. Now this answer we have already found it, isn't it? The numerator, that is 0.481. Now how do we find the denominator? Very simple. X greater than or equal to 1 means 1, 2, 3, 4. Otherwise P of 1 or 1 minus P of x equal to 0. Right? That means I think we found this answer, right? P of x equal to 0. That you can substitute it here and then find the answer. Right? Very, very simple. Okay. So let us do the fourth problem. An X-ray has a probability of 0.95 of showing a fracture in the leg. That the probability that an X-ray will show the fracture is 0.95. If 5 different X-rays are taken of a particular leg, okay, that means here n is 5. 5 different X-rays are taken of a particular leg. Find the probability that all 5 X-rays identify the fracture. The fracture does not show up. And there are two more questions. So what I'll do is I'll take success as fracture is shown. I'll just write fracture show. I'm sorry, it's fracture is shown. That means the probability of fracture being shown is 0.95. I'm sorry, 0.95. So Q will be 0.05, even though we don't use the value of Q in the calculator. So the first one is find the probability that all 5 X-rays identify the fracture. That means P of X equal to 5. So what do you do? Very simple. Go to distribution, go to binomial, go to BPD now. The X is 5 because I want P of X equal to 5. The number of trials is also 5 because 5 X-rays. And the probability of success, that is probability of a fracture showing up, is 0.95. So 0.95, and then execute. You get 0.7737. So 774 as the answer. Very, very simple. The second one is the fracture does not show up. That means P of X equal to 0. Right? The fracture does not show up. So same thing BPD, but instead of in place of X, instead of 5, enter 0. So you get 3.125 into 10 raised to minus 7. Okay, so this is the answer. No probability that the fracture does not show up. Okay, and the third one is what is the probability that at least 3 X-rays show the fracture? That means P of at least 3 of them show. That means 3, 4 and 5. So P of X greater than or equal to 3. Now as you know, BCD will only give you from 0, 0, 1, 2, 3 like that, isn't it? So what I'll do is I'll write as 1 minus P of X less than or equal to 2. Now I'll go to distribution, go to binomial. Now I'll go to BCD and I'll enter X as 2, right? Because I want X less than or equal to 2. Enter X as 2 and then fine. I get 1 minus 1.1581 into 10 raised to minus 3. So you can just leave it here. And finally, only one X-ray shows the fracture. So P of X equal to 1. Then go to distribution, go to binomial, go to BPD, write X as 1. So you get 2.9688 multiplied by 10 raised to minus 5. Yeah, so very, very simple.